Welcome to Unit 2, the multi-dimensional modeling and OLAP operations. If you want to pull ahead and secure an outstanding grade, this unit might be a golden ticket, because in this unit you cannot just memorize things. You need to understand the gist of the topics. So without wasting any time, let us discuss what we'll discuss in the Unit 2. Okay, so in this section we are going to master the multi-dimensional modeling in data warehouse, and we'll also discuss about the various schemas in multi-dimensional model. Then we'll move on to the absolute fundamental difference between OLAP and OLTP. I hope you heard the term. Yes, you did. Pause the video and try to remember where you heard this term and what does these two terms mean. Okay, the next is the comparison between the MOLAP, HOLAP, and there is one more ROLAP. Alright, and then we'll visualize the OLAP operations. What are the operations that is performed on the OLAP cube, and then the tools used in OLAP. Alright, this is the PYQ Radar of Unit 2. Let's move forward and discuss our very first topic, that is multi-dimensional data modeling. So let's start with this. For your consideration, there are traditional databases. Alright, so traditional databases store data in flat 2D rows and columns. So there are rows, there are columns, there is a simple Excel sheet in front of you, that is the 2D data, and that is how traditional databases work. And it works great for simple lists, right? But it falls apart completely when a business leader wants to analyze from multiple angles at the same time. Alright, so if he wants to see the region, if you want to see the same region in which area, which product, which time of the year, if you want to see in a same format, alright, in same time, at the same time, from multiple angles, how we are supposed to do it in the 2D flat file? We would need a cube. We would need multi-dimensional modeling of the data. That is where multi-dimensional comes in to being. So through this multi-dimensional modeling, we create a data cube. You can see over here, this is a data cube, right? So inside this model, what we do, we split the universe into two things. There is facts. Alright, so facts are what? These are the numerical KPIs we are measuring, like sales, revenue. Alright, so you see over here some. So these are the facts, right? You see some. So here we are measuring, right? And then there are dimension, the angles through which we analyze those numbers. You see there is time, quarter, alright. There is a country name, India, US, France. So these are the region, and then we have products. So these are the dimensions, and then we have a fact. So we are viewing all this data at the same time through multiple angles. This is multi-dimensional data modeling. Alright. So let's see some theory. You need to understand that it is the most important data modeling technique, and it is used to organize the data into structure and supports what all? Fast querying, analysis, reporting, right? It organizes the data around business subject and dimension, and it supports OLAP operations, which we'll discuss forward what OLAP operation is. I hope you are able to understand that this is a data cube which is created using multidimensional modeling, right? So I told you the concept of facts and measures. So fact or measure is the same thing. It is the calculated field, and dimension are the columns basically which we use to analyze those numbers. Alright. So advantage of multidimensional modeling is that it simplifies various things, and we can also perform the OLAP operations, and there are fast querying since we are viewing the data at the same time, and it is very complex as well. And it supports BI and data mining. Alright, but there are few limitations as well. It requires careful design, and there is complex maintenance when it comes to Snowflake schema. We'll discuss what that is. And data redundancy also happen, and there is large storage requirement for multidimensional modeling. Alright, I hope you got a few idea, you got the idea of what data modeling is, and that too multi-dimensional, how data is converted into a 3D cube and analyzed at the same time. Alright guys, you absolutely need to memorize this before walking into your exam hall, that is OLAP versus OLTP. Alright, so what is OLAP? What is this fuss about? So OLAP is a system designed for multi-dimensional analysis of business data to support the strategic decision making. So there are few systems that are created for particular things, right? So there is one OLAP which is particularly created for this multi-dimensional analysis. Alright, so it helps to analyze the data, identify trends, perform forecasting, and it is OLAP system mainly used for data warehouses. Alright, so this system of OLAP is generally created where there are data warehouses. It is used only with those. Whereas if you see OLTP, it stands for online transactional processing. So it is a system designed to manage and facilitate day-to-day transaction process. Alright, so wherever there is databases used, wherever there is transaction which had to be recorded every day, in those scenarios we use this system OLTP. So here we process the real-time data. Alright, we record the routines, we maintain the data integrity, all this happens. So where we have OLTP system, where we have this day-to-day transaction, we use RDBMS, that is relational databases, to store the data. Alright, there are few characteristics of OLAP, that it supports the multiple complex queries. Alright, and there are characteristics of OLTP as well. So you can pause the video and read it here and now. Now there are various type of schemas, there are various type of architectures that is used to actually model your data. Alright, so let's look at the 3 classic schema patterns that you will be asked to design on your answer sheet. So first is the star schema. Alright, so the number 1 schema is the star schema. So what we do in star schema, it is the very simplest schema. It is called star because it is in a shape of star, right? It is the most elegant and most widely used layout. Alright, so what happens is that you place a single highly centralized fact table right in the middle, and it is surrounded with the ring of dimension table on the sides. So what happens is this fact table is something which is increasingly building the rows continuously. For example, the fact table would be daily sales. Alright, and the dimension table would be something that would be providing information for the fact table. Dimension table are not increasing rapidly by the rows, they just have the information detail but about particular thing. Alright, so the fact table is right in the middle and we are surrounded by the dimension table in this. So what happens that each dimension table connects directly to the center via a single foreign key. So in a dimension table there will be one primary key that is unique, and that primary key would be foreign key in the fact table. So fact table is the mixture of all the foreign keys from the dimension table, and this is a structural layout and it looks exactly like a star. Okay, so this dimension table is completely denormalized. This means that we allow data repetition to keep the structure completely flat. So data repetition happens over here. Alright, so it is mainly used for fast querying, simple reporting, SQL analysis, and also easy understanding by the business user. So there are few advantages of the star schema, whereas disadvantages as well. So advantages would be it is very simple, it is fast querying, it is efficient and user friendly. But disadvantages come into being a massive data redundancy, because it is denormalized, because there is data redundancy, because there can be duplicate data. What happens is it gets over and over again for millions of individual product, you get a particular thing written again and again. Alright, and it eats up a lot of storage. For example, we have a column called category, and that category name like consumer electronics. For example, for the category of consumer electronics, there are millions of rows, and the consumer electronic is written millions times. So this is something which is eating up the storage unnecessary, and in real life that really matters. Alright, we don't have such a massive servers for every organization, and also it requires higher storage requirement. Like I told, there is poor data integrity, like there is denormalized, there is repeated values. What is happening? It contains inconsistency, and maintaining the data, updating it regularly is also challenging in star schema. So look at the image. You see there is an measure called order. It is the fact table, right? So in the middle is a fact table, and it is name of order. It contains order, cost, margin, and quantity sold, and there are dimension tables around it, and they're all connected with the order table, right? So there's dimension product, which contain product name, SKU, and brand. Then there is order date, which contain all the calendar values. Then we have customer. Here we have all the details of the customer, and then we have the sale person. So these are the values which are not repeated again and again. But the order table, this is a table which is continuously increased every day. So for example, you have 5,000 orders in one day, so there are 5,000 rows added in the measure table, but there cannot be 5,000 products added in one day. There cannot be 5,000 order dates. There cannot be 5,000 customers added in one day. There can be more customers, but these rows are not increasing every day. This is increasing. All right, that is why it is in between. There are all primary keys over here, and these are all taken as a foreign key in the fact table. Now we'll discuss about the very next type of schema, that is called Snowflake schema. Okay, so in Snowflake schema there is a direct evolution from the star schema. So people who absolutely hate data repetition, they go for Snowflake schema. So you take star schema, but you normalize the dimension table. So what is happening? You are breaking down into smaller subtables until all the repeating values are eliminated. So these dimension branch out like ice crystals, creating snowflake schema. So you see over here. So what is happening? We are having a fact table in between, right? But dimension tables are further divided into multiple dimensions. So it is branching out like crystal. That is why it is known as snowflake schema. So there is a snowflake pattern. So what is happening? Instead of single product table that contains the repeated categories, you split it into clean product table with different categories. So for example, there is product electronics, there is you can say cosmetics. All right, so there would be repeated value of electronic category, then category cosmetic. So you create the different dimension table for both. So the repetition of that word, of that column would be decreased, and it would save a lot of energy, time, and also faster querying. So this is how snowflake schema is created. So you see an example over here that there is sales fact in between. We have time. So see here we have product is further divided into brand and then category, right? And there is also package coming out of product as well. Then you see customer, there might be repeated country again and again, so we created another dimension for the country. You see there is sales representative, and we created territory, and then from that we created region. So what we are doing, we are normalizing the data so that there is no more repetition again and again of particular column or particular value. Okay, so let's see what are the advantages and disadvantages. Advantages of Snowflake schema is that it reduces the redundancy which exists in star schema, right? And there is storage efficiency. Of course, it saves valuable disk space by storing small unique identification code instead of massive repeating text strings, right? And then there are few disadvantages. There is slower query speed, right? To run a single report, your SQL query has to join the fact table to the product table, then to the category table, right? So there are extra joins that slow down the performance a bit, and it is also complex, right? The layout becomes difficult, and if you have non-technical managers in your organization, so then to make them understand is also a task in itself. All right, let's quickly move forward into the next type of schema, that is fact constellation schema. So it is also known as the galaxy schema. All right, galaxy schema we can say it. And what happened in this is it consists of multiple interconnected schema. So there can be a star schema and a galaxy schema and one more star schema, and they together create a there can be star schema, there can be snowflake schema, and there can be one more star schema and one more snowflake schema, and they together known as the galaxy schema. So what happens in a real world, multi-billion-dollar enterprise doesn't just run on a single business process. Okay, they have sales process, they have shipping process, they have return process. So what is happening? A fact constellation contains multiple distinct fact tables that share common overlapping dimension table. So there are so many dimensions and fact tables, and even Snowflake schema is part of that. So that is how a constellation schema, a galaxy model is created. All right. So it have multiple fact tables, shared dimension table, highly scalable, complex architecture, enterprise-wide support, right? So advantages is that it support the complex analysis. It is perfectly for designed for complex model, department corporate environments, and it also have efficient dimension sharing. So it reduces the duplication of dimension model. It is highly scalable. If you want to increase over time globally, it is also scalable, and it is flexible as well. You can easily expand for new fact tables in no time. And then there are disadvantages as well. It is highly complex design. It requires absolute architectural mastery to ensure that the shared dimension match up perfectly. All right, so there needs a very good professional in order to create this type of data warehouse architecture. So like we discussed about OLAP and OLTP, there are major differences, and which we have highlighted in front of you as well. So let's just have a quick look again about OLTP, transaction processing. So it manages daily businesses. OLAP, what it does is it manages the data for decision making. So main purpose, efficient transaction processing, whereas OLAP main purpose is analytical processing and reporting. Just remember the keywords and then reframe the reframe all the points accordingly. Use the keywords. It is very important that you learn the keywords. All right. And then there are type of data. So here it is the current data. All right, present data, present operational data, but here we have the historical data. I hope you are able to relate now, because we have discussed it a few times now. So it is highly normalized, means there is repeated data all the time, but there are particular times when we denormalize the data in multidimensional model. There are few operation performed, but in OLAP we cannot perform operation. It is read only or perform analysis. It is very fast and it is optimized for analysis. All right, so there are few more. You can read it and understand what are the other key differences between them. Let's move forward and discuss about the features of OLAP, and then we'll discuss the functions of OLAP as well. So if we talk about features, OLAP provides the several important features which helps in effective decision making for the users. First, OLAP provide the multi-dimensional analysis. Like we have discussed, it allows data to be analyzed from multiple dimensions. Obviously, there is faster querying and historical data aggregation, and we can also perform trend analysis when we have OLAP systems. The functions are quite similar to the features. So we are performing reporting. Okay, we generate report using OLAP. We summarize, we create dashboards, business reports, if we have the OLAP system. Then we perform the business analysis. We help to analyze what the customer behavior was, how the product performance was, what was the profitability by region, and then we make the strategic decisions. Okay, coming to the decisions, it has management to create the decision from the insights, which is also generated using the OLAP system. Then we also identify the trends. Then there is also data mining support in OLAP system, where we can further organize the data warehouse for the data mining applications. And then there is also performance monitoring. You ever heard about KPIs, key performance indicators? These are the measures used to analyze what how our things are performing. How, for example, there's a product, so there would be KPIs like sales, revenue, profit, and what is the vacancy. All right, so these are the KPIs. These are the measures which I use to see how my product is performing out in the market. I hope the concept of OLAP system is quite clear to you. Why we use OLAP and why OLAP is used with data warehouses, because data warehouses store large amount of data, and OLAP system is also designed for analytical processing. Now let's move forward and discuss about the OLAP operation. This is very important for you to understand. There are 4 core OLAP operations. So let's visualize these on our imaginary data cube containing. Alright, and we'll also understand what it is. So very first OLAP operation is the slice. Alright, slice. So like you cut a slice of any particular thing, what you do, you put a single cut and there is a particular slice ready for you to eat. Alright, so just like that, you select a subset of a cube. Alright, you just select a subset and cut a 2D slice out of 3D. So you see this image, what you are doing, this is a 3D slice. Consider it as an apple. So you are just cutting down the one slice. So you are cutting the 2D slice, the flat slice out of the 3D cube. So this is what slicing is. Alright, then comes the dicing. So dicing operation is used to reduce the cube one by one. So what you are doing is you are defining the sub range across multiple dimensions to extract a smaller targeted sub cube out of giant original cube. Okay, so you see over here, this is dicing. So when you just extract one sub cube out of the giant cube, so this is the mini cube. Alright, so this operation is known as dicing. For example, you only filter out the time you just want to see for 2025, year 2025, or for example, there are multiple products and you just want to see for the product laptop. For example, there are multiple regions but you only want to see for the north. So what you are doing, you are cleanly extracting a compact sub cube that is focused strictly on your high priority items. That is why dicing is used. Alright, so next is the drill down. So what happens in drill down? Drill down is used for moving up and down along the concept hierarchy. Okay, so when you want a deep details, when you want granularity details, when you want to navigate down to particular hierarchy, so that is why you use drill down. So it is basically zoom in. You're zooming, you're drilling down. So in this you see drill down, right here. So what is happening? There were 4 big cubes everywhere, right? But you are drilling it down and you are converting it into further 6 refined cubes. So this is what is drilled down, like clicking on a cell that shows yearly sales, and then you expand it to quarterly sale, and then you're clicking again to see the monthly sales, and then you see the everyday sale. So this is how drill down works. You're zooming it. And then the opposite of drill down is drill up operation. Now just like we zoomed in the drill down, now in roll up, what we are doing, we are zooming out, right? So we put up some mathematical operations, and then we aggregate it, we summarize it, and then we get the overall higher level answer to what we are looking for. For example, we want to group city level sales, that how many sales were there in north region. So we are grouping all these cities in the north region, and we are getting one summarized answer. So you see in this roll up, this is the roll up. So there we are just getting one big chunk, and we are analyzing it, right? And then there are pivot as well. So what is pivot? Pivot is a visualization operation. We just rotate it. For example, you want to have an alternative presentation of same data. Like you see, if there is item on one axis and location on other axis, you just want to switch it. That location comes on y axis and items come on x axis. So this is the pivot. You just rotate and view the data from different angle. Then there are few other operations like drill within. So when it is used within the same direction, when there is one or more hierarchy existing and you just want to switch from one hierarchy to another. And similarly, there is drill across, in which you are switching the hierarchy but from one dimension to another dimension. So you can see there is one dimension city, another is time. So when you are switching among these, then it is drill across. And for example, the dimension, there is quarter, and then in quarter you have monthly as well. So you are drilling within, right, in the same dimension. That is drill within, and changing the dimension comes in drill across. Okay, so see this example. In this example, you see when you have a city, you have a data, imaginary data of time, right, of time, of items, and of the cities. All right, and now you want to understand all the operations. So what would the slicing is? Slicing, you just took out one slice and you took the data from all the cities, all the products, but only for the quarter one. This is slicing. And then you did dicing. So what you did, you just need the data for Mumbai and Agra for quarter 1 and quarter 2 for auto and cycle. So this, you got this out, and this is dicing. Pivoting, what you did, you want to see the locations, you want to see the vehicles here and the items over here. Here it is time, and we want to see the items. That is how you do pivot. Okay, then comes the drill down. We want this quarter to drill down into month wise. What you do in that scenario? You do drill down. You see, we are now seeing the data month wise. Then there is roll up. For example, you see these two are the cities of US and these are the cities from India, and you want to combine it, you want to aggregate these, and that is how roll up work. You see America and India, so we are rolling up, drilling up, right? So these are the few major operations of data of OLAP, and it is mostly asked, and you need to create the diagram, and you need to understand by taking an example of any company and explain all the operations like this before, and then giving the example diagrammatic representation as well. So let's discuss about one more frequently asked question to categorize the different types of OLAP. So I would say there are three flavors you need to remember, that is MOLAP, ROLAP and HOLAP. So MOLAP, M stands for multi-dimensional OLAP, right? So here the data is stored in specialized high performance physical multi-dimensional array, and this would be fast because it is multi-dimensional, so calculations are pre-computed. But there is disadvantage, it requires massive storage and it also takes a lot of time to build. Then there is ROLAP. In ROLAP, R stands for relational OLAP. So what happens, the data stays inside standard relational database table, and the tool builds smart SQL queries joins on the fly using star or snowflake layout. Alright, so here we have integrated RDBMS. Okay, so it is quite slow. Okay, it is not that efficient, but it is highly scalable and it handles massive amount of data easily. But query response is quite slow in this. Then we have HOLAP. H stands for hybrid. So this is the ultimate mashup. It stores high level summarized data in quick MOLAP arrays for faster execution, but it also have deep granular transactional details which sit inside the relational OLAP, that is ROLAP. So you see, it is a mashup. So we are combining both of the things. We are combining the cubes and the tables. So summary is stored in the cubes and details are stored in the tables. So it is moderate, it has moderate scalability, it is very efficient, but it is highly complex. You see, to create it and to maintain it is quite complex. Alright, I hope you understood how this is. You can simply pause the video and read all the further differentiation among them. So this is mostly asked either between MOLAP, ROLAP or MOLAP or HOLAP. So you should have the information about all the three types of OLAP existing in the system. Alright guys, let's discuss these two topics about hypercube and EIS system, which are almost invisible in your syllabus, but I think it is very important to know about the concept. So let's talk about the hypercube. We all know what an OLAP data cube looks like, right? It's a standard 3D block where you can track the data across 3 dimensions, which we talked about, which is product, region and time. But let me ask you a question. What happens when the company expands and need to track the data across 4 or 5 or 10 dimensions simultaneously? Like we want to add customer segment, sales channel and currency all in the same cube. What happens? You can't draw a 5-dimensional cube on a flat piece of paper, right? That is where hypercube comes into rescue. So hypercube is advanced multi-dimensional data structure used in OLAP, where we are storing and analyzing the data across multiple dimensional, over 2 or 3 dimensions. So it is the extended concept of 2-dimensional table, and it allows the user to perform all the complex business analysis efficiently. So you see, the hypercube is an advanced cube, and it converts the 3D cube into n number of dimensions. So there are n dimensions, there can be multiple. Alright, so hypercubes are mainly used in OLAP system, in BI, in multidimensional analysis, and it enables to analyze the several perspective simultaneously, right? So it helps a lot. So why businesses rely on hypercubes? Why do we need this advanced architecture? Because modern business logic is highly complex. Imagine you are analyzing an e-commerce platform sales performance, right? So to get the full picture, you need to filter data, right? You need to filter data. What is the time, which quarter, which product, which model of the laptop, which city, Okay, which region, which sales channel, which customer demographic? Was it a corporate buyer? Was it a student? Which channel? Was it mobile app? Was it website? So a hypercube mathematically links all these dimensions. I listed 5 dimensions, so it would link all these dimensions into a single unified matrix. Alright, so this is how, and it allows the executive to run massive multi-angle search. And hypercubes are very effective in this highly overrunning business these years, right? So we use hypercube a lot. And then you need to understand the concept of EIS, that is Executive Information System. So this is the actual software tool that sits on the CEO's desk. It is the Executive Information System. So look, a company's CEO or a managing director does not have the time to write SQL queries, right? They don't have time to read the raw data logs or scroll through messy 50 pages spreadsheet. They need a bird's eye view of an entire global business operation under 10 seconds. So where would that be? That is where EIS, that is Executive Information System, comes into being. So it is highly specialized information system built specially for the top level executives, alright, to provide support for strategic decision making. So what you need to understand the features, it provides the strategic support. It does not focus on daily operational noise, it just filters out the background and it only provides the main thing that is required. And there are graphical dashboards and reports. You see, it translates millions of rows of backend data into beautiful, impactful graphic, which is very easy to understand and visualize. Then there are trend analysis, drill down analysis. So this is a huge feature, drill down capability. So if the CEO looks at the main dashboard and notices the overall revenue has dropped by 10%, so then they can click on a specific graph, like they can click on a specific quarter and drill down exactly to the layer where they can actually understand the crashes happening. Alright, and then there can be trend analysis as well, in which it displays the historical performance. There can be real-time information access. It streams live, verified data feeds directly into the EIS data warehouse, and it ensures that corporate leadership is making the decision based on the exact reality of the market right now. And there are also KPI monitoring as the key feature of EIS. So it tracks the ultimate health matrices of the business, like net profit margin, customer acquisition cost, and what is the turnover rate against the company's annual target. So it really helps, and EIS system is very important in the organization to build an efficient system. This is exactly how you conquer every concept in Unit 2. Now, before we march forward into the absolute core of the syllabus, that is Unit 3, it is time for you to have an active recall challenge. I want you to hit the pause on this video right now, grab your notebook and see if you can tackle these repeated exam radar questions. Can you explain the difference between the types of data mart? Can you quickly draw the OLAP cube and explain the different operations on OLAP? Can you differentiate between a snowflake and a star schema? Test yourself, and if you can drop these answers comfortably, congratulations, you're on track.